Hi, this is the first part of two videos on squares and square roots. And that's actually a lie. There's actually a few more videos on square roots, but this is the first part of introducing what is a square root. That's a great question. Here we go. First off, before we do square roots, we need to know, what do I mean by taking the square? Hey look, review, taking the square. Taking the square of a number is just saying, what is that number times itself equal? And that's written as m squared. So whenever I see m to the second power, you don't say m to the second power. You say m squared. How come, Mr. V? Well, that's a great question. That's on the next page. So first off, it's kind of one of those things where it is expected that you basically have all the way through 15 memorized. Sitting there, like, if I ask you what's 1 squared and your automatic answer is 2, you're wrong. True statement. It's just knowing, well, 1 squared is 1 times 1, so that's 1. This mechanical pencil, if you watched the other video, you saw me yell at it for a minute. Is 1. It's over. I'll use this horrible broken mechanical pencil over you anytime. I apologize for that, parents that are watching this. I love mechanical pencils. That one sucks. 2 squared is 2 times 2. That's 4. 3 squared is 3 times 3. That's 9. 4 squared is 4 times 4, 16. 5 times 5, 25. 36, 49. Yeah, you literally, I will give you a paper blank of all of these and I'll tell you fill in a table. That's the test. No scratch work allowed on it. You just write down what they are. Either you know it or you don't. 64, 81. Keep thinking I'm joking. I'm not. I so do it. This is something you just got to know. It's like knowing 3 times 3 is 9. Not no in German, for you German people out there, but 9 is in the number 9. 11 times 11, 121, 144. Here we go. 13 squared, if you didn't know, is 169. 13 and 14 are kind of funny because it's just kind of backwards. The last two numbers are just flipped. I always thought it was kind of silly. And this one is 225. Whew. Okay, so that's that. Like, no joke. This is something you need to know. All these numbers, by the way, are called perfect squares. And you might say, why are they called perfect squares? Haha. Well, all the numbers are whole numbers, and you're gonna see why right now. The square roots. The square roots are basically, if I ask you what the square root of 1 is, it's find all the a's so that some number, when this a is multiplied to itself, is equal to that number. So here we go. What times itself equals 1? Well, 1 times 1, so 1. 4 times 4. 2, 3. So if I'm asking you what the square root of 1, 4, and 9 are, this is it. The square root of 16 is 4. Square root of 25 is 5. Because 5 times 5 is 25. This is 6. This is negative 7. This is 8. Hey, Mr. V, that ain't funny. You're right. 7, 8, 9 is a horrible joke, and that's why 6 is scared of 7. Because 7, 8, 9. I thought it's a great joke. I don't get to say it that often. It's a very great joke. No, not negative, dude. That ain't cool. Oh, right. Well, negative 7 times negative 7, because it's all numbers that multiply to themselves. See, a negative times a negative is a positive, and that's 49. No, all of these are positive. Yeah, I did. Yeah. Here's a little tip. There's always 2. Oh my god! There's a positive, which everyone always automatically knows, and a negative. So, if they just give you a number and say, hey, what's the square root of this? There's two possible answers. There is a positive and a negative. What? Oh yeah, we're not done. We got to come back up and fix this. 1 and -1. 2 and -2. 3 and -3. OMG. Are you serious? Oh yeah. I wanted to come down here, so I put +7. The positive and the negative are both the square roots. They both share the honor that if -6 times -6 happens, it equals +36 also. Yep, you see me, just go for it. 13. And if you're looking, look on the table that's next to this. Isn't it kind of backwards? It's kind of the inverse of what's going on over here. -9, -10, -11, -12, -13, -14, -15. Whoa! Like, both of those are, every number has two square roots, a positive and a negative. You might think to yourself, isn't there a little bit of an easier way of writing this? Actually, there is. You can write this as plus or -1. You can write this one as plus or -6. That is a little bit of a shortcut. It means positive and negative. Go and finish the rest of the table. I'm not going to do that during the video. But the square roots, there is a positive and a negative. Also, you can only take the square root of a positive. And we're going to talk more about that in a minute. Let's get to it. Next part. I wanted to just reflect on life a little bit. If you notice, the inverse started to happen. And you might be like, yeah, inverse, yay. Let's go back in the day of last week. If I add something and then I subtract it right away, I get my original number. The S's cancel. If I take something away and then I add it right afterwards, I get the same number again. These don't matter because they're inverse operations. If I multiply first and then divide, I get that original number back. Unless it's 0. That doesn't work for 0. If I divide first and then multiply by the same number, they cancel each other out because they are inverse operations. If I square some number, how do I get that number back? I take the square root. And that's the symbol for square root. If I square root something, how do I get that number back? I square it. These undo each other. There are certain rules and little tiny things about both of them, but they undo each other. New operation, square root. And a little bit of a history. Why do we say square? Well, the area of a square is the same number times itself, right? Because a square is equal on both sides. So 3 squared is 9. That's why we say square. Let's take the square. That's why. Little history for you. Math was invented by farmers and market people. I'm not kidding. Seriously. People who do business invented math. It wasn't us crazy mathematicians at first. It was Farmer John and his lovely sausage bacon patties that I love. Moving on. The square root of a number is one of the two equal factors of that number. 9 is equal to 3 times 3. That's real obvious. I need to think about what number times itself gives me that number back. And if you notice, 3 squared, the square root of that is 3. I just keep one of the 3's. There are 2 3's, but I only keep one of them. Another thing is this. The solution must be positive if it starts with the square root. What about over here? They didn't start with square roots. That was just name the square roots. Very different question over here. So if it starts with the square root, you don't have to put two different answers. If it doesn't start with it, you have to put two different answers. Let's do a few examples. Just get to it. Mr. V, I saw a couple of those things you just put on there. They weren't on, dude, not cool. Just do it. Square root of 81 is, and I'm going to zoom in a little bit for this. No, not, come on, come on, come on. Come on, come on, come on, come on, come on, comedian. Sorry. Square root of 81. Well, that's 9 squared, isn't it? That is 9 times 9. Well, that just equals 9. Easy enough, right? Mr. V, that ain't funny. That's 88,100. Yeah, but think about it. You know what the square root of 81 is, don't you? Yes, I do. Let's play with it. This is equal to 81 times what? Think about scientific notation. What is it? 81 times, I moved the decimal twice. It's 100, isn't it? There's an awesome little trick that says, and it's a trick, but there's a reason. I'm going to give you the reason in a minute. I can pull this apart and say, what is the square root of 81 times the square root of 100? So I can do them separately. I can pull it apart because of if it's multiplying, adding, no, subtracting, no, multiplying or dividing, I can pull them apart. So this equals 9 times 10. Well, that's equal to 90. Perfectly legal move. Totally fine. And those are more of the type of questions you will see on a test. With the compound multiples that we got to pull apart. That's it. Let's see, next one. Square root of 784. Mr. V, you ain't funny anymore. That ain't cool. You're right. The first thing I'm going to do is I'm going to factor this thing out. This is equal to the square root of, let's see, I know I can factor 2 out. 78 divided by 2 is, let's see, 78 divided by 2, I know 80 divided by 2 is 40, so this must be 39. And then put a 2 at the end. Check me on that. 784 divided by 2 is 392. That doesn't help. You're right. Let's do it again. I'm gonna keep that first 2. I know I can get a second 2 out of it. 392 divided by 2, and this one I'm gonna do. Sorry, don't do that one. Oh, so that symbol, the square root and the divide symbol, easy to mess up, right? Pay attention to that. See, that goes in once. Bring down 9. That goes in 9 times. We're in minus 18. Hey, look. Times 196. Take a moment. We know what the square root of 196 is, don't we? We know that this is going to be equal to the square root of, 2 times 2 is really 4. Times the square root of 196. I am out of room down there, so I'm going to just do this. Well, the square root of 4 is 2. Go back to your table. It's 2. Times the square root of 196 is 14. Right? 2 times 14 is 28. So, the square root of 784 is 28. It's taking your time and breaking things apart. If you rush, you'll make mistakes. So take your time and just grind through it. Holy cow. Let's think about D for a minute. What is that? What? Do I multiply first? Do I square root? What do I... If only the order of operations told me what to do. They do. What? No, they don't. Think about order of operations. Whenever I write them, I always say this. We have grouping symbols, exponents. We multiply or divide first, add or subtract. These are inverses of each other. Multiplying and dividing are inverses, and they happen at the same time. Adding and subtracting, they're inverses, they happen at the same time. Square and square root. Well, square is an exponent, and the square root is its inverse. So they should happen at the same time. So you do square roots with the exponents. A little bit of a foreshadow. The square root of 64 is also equal to 8. Sorry, wrong. Is also equal to 64 to the 1/2 power. Exponents can be fractions? Yes. Don't worry about that. We're not going to do that this year. But it can be written as an exponent. Mr. V, you just ruined my life. Square roots, I didn't have to worry about fractions lately. Yeah, well, you're going to have to next year. Surprise! Let's do this. 7 times the square root of 64. Well, that's 8 squared, right? So really, it's 7 times 8. You just take the square root, and then order of operations. Now I'm multiplying. 56. Great. So that's a little trick right there, or a little. That's a good problem. I don't know what the square root of 2 is, and I don't know what the square root of 8 is, and I don't know either, because they're like decimals that go on forever. There's no point. Well, what we can do though is this. Remember how up here we pulled it apart? Well, we can paste it back together also. Because if you've noticed already, what's 2 times 8? I can redo that. 2 times 8 is 16. Hey, look, the square root of 16 is 4. I hit so many different ideas. It's craziness what type of problems I can give you. Really take your time and think, okay, that's order of operations. That's way too big. I got to factor that apart. Maybe make a factor tree. That's pretty obvious. 81 and 100. Okay, like take your time, breathe, don't panic, as the great Hitchhiker's Guide to the Galaxy once said. It's a great book. Go read it. Have a good time. That's the part 1 of square roots. Get ready for the next part.